Creating alternatives is a key part of the ideation process in creating an interface. When an interface designer explores multiple alternatives, it leads to better designs. They can also compare design concepts to provide stronger critiques, and it can increase the diversity in the overall designs. However, designers face challenges in creating alternatives, like fixation, which makes it difficult to think of new ideas, and second, it's time-consuming to create each alternative manually as a prototype. To help designers overcome these problems, research tools like Designscape and Sketchexplorer provide automatically generated alternative suggestions. These tools have two main limitations. First, a designer cannot provide any feedback on the alternatives to help the system generate better alternatives in the future. And a designer cannot control what alternatives the system generates or define any constraints on them, so the layouts can end up violating the designer's interface semantics. So, to help designers overcome these limitations, we built Scout, which is a system for rapid exploration of alternatives. In Scout, a designer can specify high-level constraints and interface elements that they want to maintain across the alternatives. And Scout uses a constraint solver to synthesize alternatives. These are then shown to the designer, who can then interact with them to give feedback or update the high-level constraints at any point in time. So within Scout, we explore a few different research questions to advance upon previous work. The first is, how can we give designers more control over alternative generation by letting them define constraints on high-level interface semantics? So I'll first define what we mean by a constraint. So we know designers often have high-level semantics in mind for their interfaces, like which elements should go together, which order they should be kept in, and which elements are the most important. These reflect basic rules the designer wants to define on the interface layout and semantics. One thing in common with these types of constraints is that the relationship between the interface elements the designer wants, like the grouping, corresponds to their spatial relationships on the screen. Spatial constraints are common in interface layout tools, like Apple's Auto Layout, where an interface developer would express some rules about interface elements as spatial constraints, like this constraint, which states that the green smoothie label should be 20 pixels above the subtext by OEM. So a designer could express some constraints like this to help a system generate alternatives, but these kind of constraints can be difficult to reason about, and they're not really suitable to express high-level interface semantics like emphasis, or which elements is the most important. So in this work, rather than the designer defining the requirements for an interface through low-level spatial constraints, we let them express high-level constraints that define interface semantics, like which elements are the most important. So the next question is, how can we use these constraints then to help the designers rapidly ideate and visualize alternatives? So how can we go from these high-level constraints the interface designer defines to have a system help them ideate and visualize layouts? So to answer that, we leverage past work on constraints in user interface builders. Constraints have a long history in interface creation tools like Sketchpad and research tools. Constraint solvers used by these tools can generate layouts that satisfy a set of constraints. However, the focus of many of these tools is to help the interface designer create one unambiguous solution to their layout or a few for alternate layout dimensions. In contrast to prior work, the insight we make in this work is that we can leverage this ambiguity for ideation and can have the constraint solver generate lots of alternative solutions to satisfy a designer's constraints. So this is our system Scout, which presents designers with a gallery of layout ideas for their selected interface elements. And they can explore and interact with those layout ideas. To walk you through this process for an interface designer, I'll introduce Eunice, and she wants to redesign the layout of this smoothie app screen. She starts off by importing her components into Scout to explore some alternatives. She adds her components to Scout's outline, and then adds some high-level constraints to them. She can add several kinds of high-level constraints, like an alternate group, which tells Scout to use only one of the grouped placeholders in each layout to help her visualize different variations, and emphasis, which helps her provide a focal point for the interface. Scout will then try to make that element larger and emphasize it in relation to other elements. And Eunice can also group elements that are related and unrelated, so Scout can keep them together and in her desired order. She tells Scout to show her some layout ideas, and then gives feedback by keeping and preventing properties that she likes and doesn't like. Her feedback appears as an annotation in Scout's outline tree. and she saves a few different layouts that she wants to keep. And in the end, she exports her designs out of Scout to further refine them within her favorite design prototyping tool. So now that I've showed the ideas behind Scout, I'd like to talk a little bit about the architecture that makes it work. Designers interact first with Scout by providing high-level constraints on their interface elements. These elements and constraints go through this constraint resolver that generates a layout for a set of interface elements by assigning values to a set of layout variables like alignment, margin, and padding. And then the constraint solver will iteratively check these assignments against a set of low-level spatial constraints encoded into an SMT solver called Z3, and that returns whether the layout is valid with respect to the designer's high-level constraints and a set of basic design quality constraints. These layouts then go back into the Scout interface. The constraint resolver consists of a full set of constraint formalizations, which we implemented to translate between the designer's high-level constraints and the low-level spatial constraints required by the solver. So within Scout, we developed these translations to convert high-level constraints into low-level spatial equations. And another consideration in building Scout was scalability. So due to the size of possible layouts Scout can generate, we had to get creative to have the solver generate many layouts interactively. So we built Scout as a multi-threaded application so that it generates multiple layouts using these different algorithms in parallel. We also thought it was important to help the designers prioritize good layout ideas. So we developed a graphic design cost function that formalizes different properties of good layouts like alignment and balance, and produces a score to help rank the layouts in Scout's interface. Lastly, designers can give feedback to Scout. So when a designer interacts with one of the layouts to give feedback on a property of it, that gets added as an additional constraint into the constraint resolver. And it then returns some new layouts that match the designer's new set of constraints. So after developing Scout, we conducted a user study with 18 designers to understand more about how Scout impacts the diversity of the resulting designs, and how designers imagine using such a tool within their process. We studied the following research questions. One is, does Scout help designers generate more diverse interface layouts? 2, does Scout help designers generate higher quality interface layouts? And 3, finally, how does Scout affect designers' processes of exploring potential interface layouts? And we gave them a task, which was to redesign the layout of a mobile app design wireframe. And we had them create 3 diverse alternatives to make them as diverse as possible. The designers had conducted a desirability study, which is a type of study where users assign descriptive keywords like dull or familiar, which had been assigned to the social media app on the left, with the goal of having their final designs result in the goal keywords of clean and compelling. We gave the designers 2 sets of predefined components that we selected to be from common and familiar types of app screens, like a social media and a weather app screen, and gave them these component palettes to use. Our evaluation had 2 conditions. The first was a Scout task where the designers used Scout and saved their top 3 designs for 20 minutes, and then they exported them out to Adobe XD for refinement. The second was a baseline task where the designers had only scratch paper and used Adobe XD to create their 3 alternatives. Each designer completed both tasks, which we counterbalanced along with the scenarios of social media and weather tasks, and we didn't give them any particular high-level constraints to use, so they could basically use Scout however they wished. So for our first research question, we studied what do we meant by more diverse. So to do this, we created a spatial diversity metric, and that produces a score to help us evaluate how spatially different two layouts are from each other, which you can read about in our paper for more details. We computed 3 of these spatial diversity scores for each designer on the 3 pairs of designer layouts for both the weather and social media scenarios, which meant each designer had 6 total diversity scores. The designs the designers created with Scout were 12% more spatially diverse than the baseline pairs. So Scout did help the designers come up with more diverse layouts overall, which was statistically significant. And Scout also helped the designers create layouts that were more spatially diverse than the original layout. So I computed these spatial diversity scores for each designer created layout with the original layout. And again, that was a total of 6 pairs. And the Scout created layouts were 15% more spatially diverse than the baseline pairs in this condition as well. And finally, we computed we wanted to measure the overall diversity among all pairs of designs across all designers to see Scout's impact on the collective set of layout ideas that the designers could explore. And using that, Scout increased the overall mean spatial diversity by 25% for the social media task and for the weather by 10%. And that was each measured across 351 pairs of designs. So we know Scout did help increase diversity. So then we next evaluated the quality of the layouts created by the designers using Scout and using the baseline tool. Here are some examples of designs the designers created with Scout and with XT for both scenarios. And we had 2 independent designers evaluate the quality of each layout in terms of layout properties like alignment and visual hierarchy. And while we thought maybe there would be a difference in terms of overall layout quality of the designs, we didn't find any significant differences in quality. So since the Scout task did require to set up the high-level constraints first, perhaps the designers may not have had enough time to really refine their designs at the end since they were also learning a new tool. We also interviewed the designers as well after each task and at the end of the study and did some qualitative analysis, and that revealed a few key themes. Like first, 9 of the designers said that Scout helped them think of a new idea they didn't think they would have had on their own. Some ideas were also different than a typical social media or weather app screen. One designer even said Scout made them open to different ideas. They said, "I thought, wow, it's square, and I don't like it, but because it said diverse and I had the option to easily look at different ideas with different shapes, I was more open to it. If I had done this on my own, I probably would have used the circle and nothing else." Second, 14 out of 18 of our designers said they would use Scout to ideate or quickly visualize layouts or to get unstuck. Finally, designers followed a more structured and a less linear design process with Scout than when using the baseline. A linear process in this case would be them copying and pasting one design artboard to begin transforming it into another, or mentioning that was a process they followed. Designers also mentioned thinking about concepts like grouping, emphasis, and order significantly more often with Scout than in the baseline task. And even reflecting on their past approach to creating alternatives, one designer said they struggled with that. They said, "It's something I need to work on. Usually I just end up working on one idea and then iterating on that single idea.